Good afternoon, everyone. There we go. I'm Ted Venema. I'm Vice President of Business Development for Frozen Mountain Software. I have with me Adam Banenhoven, who's one of our professional services staff. Thank you for taking the time to have a look at our Frozen Mountain demo today. So, who is Frozen Mountain? What are we going to show you? Frozen Mountain produces SDKs for developers. So we're a very white box company. In other words, what we provide you are toolkits and access to the lower level stuff and the lower level components of real-time communications, both peer-to-peer and non-peer-to-peer, in order to build them into your own application. So we're not at all black box. It's not a service you use. You actually license the software. You use the various components and build them into your application to be used as part of your application. We center around two main products. Icelink is our WebRTC product. Icelink is actually provides WebRTC services across all the various platforms. And it's sort of been mentioned by a few people already, I've heard in some of the sessions at this conference. We do that actually by providing an API that's a little higher level than the actual WebRTC API. We provide our own API. And the reason we've always done that is not because we believe we need more APIs, but it's the only way we figured out to get around the issue of the fact that not all the APIs are the same. Microsoft is not necessarily doing the same thing, and that sort of thing. So because we use our own API, what happens is you're running on Chrome, then we detect the fact that you're running on Chrome, we turn around, we use the Chrome implementation. Why not? The browser vendors are always going to be able to do things better than we do. Today on Internet Explorer, if you use our stuff, then you will find that you're using an Internet Explorer plugin. It's the only way to go. When Microsoft comes out with ORTC, in whatever shape that is, we're sure they'll come out with something, then we will just take the plugin out, and you'll be able to go ahead and use ORTC through the same API you're using today. We'll manage the differences that occur, because no doubt there will be differences. Equally, we also provide the same capability on all of the native platforms. We have many, many customers that are looking to deploy applications, not just in the browser world, but in the mobile world, on tablets, okay, in a variety of different environments. And so we provide that same API. So effectively, what we're seeing a lot of is WebRTC without the web, saying it's a really good standard, why can't we just use the same thing everywhere? And so that's what we do. Okay, we also already support Vp8 and H.264. I think the latest I heard now is it looks like the WebRTC is going to support both, so some of that battle is out of the way. So it looks like certainly H.264 is the way it's going to go long term. We already support them, we're already roaring to go on that. On the non-peer-to-peer side, we also have what we call WebSync. WebSync basically is a server-based product that does all forms of server-based communication over the internet. This includes signaling, session management, HTTP push, synchronizing browsers, and doing things like messaging and chat. You don't need to use the wait or UDP channels in order to do some things over peer-to-peer. Sometimes you do want to use actual server-based technology. We provide both components in an open fashion so that people can go ahead and use them as appropriate in their applications. So what we're going to quickly show you then is something that a lot of our customers have asked, since we have so many platforms, is how do I develop applications with the least number of code bases? And what a lot of our customers are doing is actually using Xamarin. For those of you that are unfamiliar with it, it's a cross-platform development environment based on C# that allows you to develop iOS, Android, Windows, and Mac applications from the same code base. So we can have one version of the app running that way. The same app can then be written in JavaScript, and you actually have one app, two slightly different code bases that actually can run on all of the platforms we stated. So I'm going to let Adam go ahead and show you what those code looks like a little bit and how they actually run.
Thank you, Ted. So I'm just going to start with just a quick look at the code for both Xamarin and then for in JavaScript, so you can just see how it's the same. So this code here is how you actually start the conference. It's identified by a string, which happens to be, in this case, a slash with a session ID. It can be anything you want. It's typically like a path. And you can process that on the back and do other useful things on the backside. And then we have callbacks and to handle failures and success. And you can do all sorts of things in that case. Oops. In JavaScript, it looks exactly the same. Different because, of course, this is JavaScript and not C#, but it's still substantially the same. You have join a conference and you give it a name, and the conference is the object that contains the streams and the local media and all that fun stuff, and then failure and success conditions. The nice thing is that this signaling CS file will run in iOS and Android and native Windows and native Mac if you're running on Xamarin. So I was going to show you how well it compiles, but it's entirely boring and not really worth it. But you just run it from, this is actually running, I just hit compile a few minutes ago, and it's running. So this is all running locally on my own server. I have the back end running already and a browser connected to it. Oh, incidentally, all of this code is available to you in the community downloads. You can just download it, look at, we have all these examples for all the platforms. You're welcome, we encourage you to do this yourself. So here's on the browser, I'm going to join, and I'm going to give it just $9.99 because it's easy to type. So this is me connected here, and I have also, we'll pull this up in QuickTime. So this is not what's supposed to be. There we go. Okay, that's the problem. So now I'm running this in, so now I have a connection between the browser and my tablet here, and unfortunately QuickTime is a little slow in this, so I see it faster than you do on here. But because this is a native app, I can do things like double tap, and now I'm showing the other side. So now I'm showing all you, and if I switch to here, network is what it is, but so I can switch this without changing what I'm doing. I'm switching between them, and I can do other things. I can change the volume. I can add size, resize the previews as well if I wanted to add that code myself. So that's the main part of it. I'll just go just show you some of the similarities. So this is a class we use that I wrote, or it's in the demo, that wraps the WebRTC stuff. So it's very similar. So we're calling get media, and we're passing in Booleans for whether or not you want audio and video. But of course, because we have control over the capture, we can decide what the height and the frame weight is. We also have the opportunity to change how it's presented. So, for example, you'll notice that, well, that's not good. There we go. So here oh, that's why. This is taking over the whole screen. Now, that's in part because I've told it to take up the whole screen. If I change the scale parameters, it would letterbox it, right? But in this case, I want to use up the whole screen, so I've chosen that option. But other than that, it's identical, what you would do with a regular WebRTC, with provision, of course, for this is C#, not JavaScript. And it's all very simple. Our signaling is also similarly very simple. We have classes that handle this, and you just connect to things and you take events, and you can do whatever you want. I've controlled video, the volume and things like this. These are all within your control because you have access to the device features itself. If you're not, let's say you're working on for a native Windows app or native Mac app, maybe your video stream you want isn't a camera. There's all sorts of things that aren't cameras. So you can write your own video capture provider, and it will send up frames, and whoever's on the other end, whether they're on a device or on a browser, they'll receive that. So you have all the flexibility to add the features you need, and that's really all
No, that's good. That's it.
Thank you very much.